Multiplying radical expressions is the same as multiplying polynomials. So if you have a monomial before the grouping symbol, you have to do the rainbow method and distribute. So this will end up to be square root of 5 times the square root of 3 minus square root of 5 times the square root of 75. Now, these two can be combined together into square root of 15, but these two don't combine them. Why? Because 75, from the graphic organizer, is the same as the square root of 25 times 3, correct? And what's the square root of 25? Well, that's a perfect square, so it's 5, and then radical 3 stays inside the radical sign. So going back, this will become square root of 5. I'm going to write the square root of 3 next, and then I'll put the square root of 25 last. There you go. So this becomes the square root of 15 minus, together these two make another square root of 15, and then the square root of 25 is 5. But I'm going to put the 5 right here in front. So you can think of this as 1 square root of 15 minus 5 square root of 15. So if the coefficient here is 1, then you can pretty much, subtract the integers, right? So what's 1 minus negative 5? Well, you get negative 4 radical 15. So that's the final answer. How about here? So let's do the rainbow method again. So you have 8, which is an integer. The integer here is invisible, but it's 1. So 8 times 1 is 8. And then you have square root of 3 times the square root of 2. Once you get the hang of it, you can combine them already into square root of 6. Okay? So right now I'm just showing you the long way so nobody gets lost. And then let's make another rainbow from here to there. So plus 7 square root of 3 and square root of 32. There we go. Now there is an advantage of writing them out instead of combining them right away. For example, here you can break it down further. So you can keep the number smaller, right? If you don't multiply them together. So this one will become 8 square root of 6 plus 7 square root of 3. Let's pause and take a look at the 32. Now, what perfect square number goes into 32? 16, correct? 16 times 2. And the square root of 16 we know is 4. So we're going to rewrite that as, I'm going to write the square root of 2 again, so I can combine it later with the number, or with the radical that is not a perfect square, and then I'll put a radical 16 last. So this is 8 a radical 6 plus 7, that's a radical 6 together, and then the square root of 16 is 4, but I'm going to multiply it to the regular number, which is 7. So this is 8 a radical 6 plus 28 a radical 6. And these two end up to be like terms again, because they both have radical 6 in common. So we're going to add 8 plus 28, and we get 36 radical 6. So that's the final answer. Let's look at more examples. I think this is my last slide. Oh, where is it? Okay, so let me just get this out of the way so we'll have more space. Alright, so 2 radical 5 minus 4 quantity squared. Well, what does that mean? This means that you're multiplying the expression by itself, right? So you can do your rainbow method again. So 2 radical 5 times 2 radical 5, that gives you what? So that gives you 4 radical 25. Get me? Because 5 times 5 is 25. And then when you do this rainbow over here, what's 2 radical 5 times negative 4? So the 4 gets multiplied to the 2, but not to the 5. You get negative 8, negative 8, radical 5. Okay, now let's see this. Negative 4 times 2 radical 5 is the same as negative 8 radical 5. And then negative 4 times negative 4 is positive 16. So, combining like terms together, this is for radical 25. But what's radical 25? It's 5. So 5, if you write this as 5, 5 times 4 is 20. Okay. Now, these two are like terms because they both have square root of 5. So negative 8 and negative 8 become negative 16 radical 5. And the last one is the constant, which is positive 16. So simplifying further, 20 plus 16 is 36, and then bring this down, minus 16 radical 5. Okay. And for the last example, as cube root, so let's do the rainbow. That's going to be cube root of negative 4, times the cube root of 2, and then minus cube root of negative 4 times the cube root of 16. Okay. Now, what's 4 times 2? Negative. It's 8, right? So that's cube root of negative 8. Minus, let's combine these two together. So cube root of negative 64, right? Okay, now, does negative 8 have a cube root? Yeah, because the cube root of positive 8 is 2, right? So that means the answer here is negative 2. Now, what about negative 64? Well, the cube root of positive 64 is 4. So that means the cube root of negative 64 is negative 4. But be careful, you have a minus sign there. And then the answer to this expression is negative 4. So negative 2, this will turn to positive. So negative 2 plus 4 will become positive 2. So that means this expression here simplifies to positive 2. That's interesting. Alright, so as you can see, how we did polynomials before pretty much works with radicals. The only additional thing that we had to learn is actually how to simplify radical expressions. And depending on whether they are perfect squares or perfect cubes, you have to break them down, either break them down or you can combine them, such as what we did here, so we can form a perfect cube number. So I hope that helped, in explaining and showing how to perform operations on radical expressions.